Georgia could, if they win against Auburn,
It's
They win. They're
they probably they may go to the 1 seed.
I don't think they're overtaking Clemson.
Clemson's
I think
number
Clemson's
one.
resume is too good. Oklahoma's
That's true. Their resume is strong.
Oklahoma and Clemson's resumes are too much. They're way much better than Georgia's. I think.
Wait,
So
they're
Georgia would be like
ranked
2 or
much.
3,
Georgia would be 2 or 3. I think Georgia. If Georgia wins, they'll be 3, and then
They
which
won't
means
win.
they play like Oklahoma.
they
Or
do. They
something.
play Oklahoma or Clemson, or probably Oklahoma.
They won't win.
Georgia, I don't think they're going anyways.
Auburn's winning.
Did I tell you I think I told you this. I have a ticket to the national championship.
Really?
You should buy one every year just in case Michigan gets in.
Oh no.
Oh, no?
No.
You
Yeah,
just have one?
my father-in-law
That'd be a lot of money.
is like with a company, so like he's
Oh.
a CEO of a company.
Okay.
So he buys all this. He's like, hey, I got a ticket. You want to go? I'm like, yeah, I want to go. I don't care who's in it.
Oh, coach, can I
Auburn
ask
makes it, my brother might.
the questions
Yeah.
now?
I want to go.
So like,
I'm going
you
on.
have to win.
I think we should also recognize the best dress.
Maybe we do that when we give a free ticket to the best dressed,
And then
and then we just do a raffle for the other ones.
Yeah.
Is that cool?
Yeah.
Hey, here's the thing though. If we're gonna do it, if we're gonna have it, it doesn't mean anything unless we promote that.
that is true.
You know what I mean? We just got to do that. But hey, I'll come through with that stuff if you come through with the other stuff there. Okay? Sound good?
Yeah.
Do you think if we could get people to a tailgate if
This
we
is how
said
like I imagine like David and Goliath looked like in the Bible when they like dueled.
thank you?
That's like the size difference.
You're a hero. That's what
Yeah.
he's saying.
Thank you.
yeah,
Thanks,
exactly.
Patty.
You're David. That's a good
That's
one.
not even wrong with that.
I don't know about that.
I'm right.
I'll have 2
How
unexcused
about
absences:
this,
study
is it
hall
okay
and
if
chapel.
we
What the heck?
talk
What
about
position did he play?
because it'll take a little bit for me to
quarterback?
discuss this. We kind of
Short guy.
Linebacker. Let's take a little while for them to explain.
Fans.
This one and that one especially. This one.
He said he
You
played
like running
linebacker.
LB left bench.
LB.
He was the
Standard
LB.
deviation.
Yeah, it's the
Left
Y.
is not true.
He played left
Because
bench.
when you think of standard
Water-
deviation,
water
you're
boy.
greater than 1 or
Water's wet.
Water
or
boy.
less than
He
that.
Whoa,
wet.
Because of that, that's why this
Water's wet.
Is water wet?
Yeah,
Hey,
bro,
you
water's
said
wet.
falls
Just
out.
wet
Don't
that
believe
up.
any specific
Well, I wouldn't even shoot again.
Water's
I'm gonna shoot again.
Isn't that
I
true?
don't think
Water is not
Do
wet.
it.
Water's not wet. Water's not. Wait.
Wait, Matt, send me a ball.
Wet.
Oh,
Send
a ball.
Thank you.
Whoa, God, someone agrees. Thank you.
A lot of people
trust me. I try to
However,
understand.
with probability,
Oh.
right? The probability that I'll flip a coin, it's got to be between 0 and 1.
Oh,
Does that make sense? So that would be that one. The other two, could we hit on later on? And then we can talk through it.
Okay, thanks, Juan.
That'd be awesome. I think I'll be here at 8.
Knockdown.
Is that cool?
Thank you.
Thank you, V.
Over V.
Oh.
V?
No, we're not shooting over V.
I just almost balled
Poor
out
V.
over V.
Over.
Y'all messing with
No,
me.
bad.
Get that out.
Oh, Jerry, best
Yeah.
assist. Jerry's my assist man. Every time. Oh.
That's
Oh,
fine.
the guy, the dribble down.
Yeah,
One
see?
shot.
Yeah.
Up here, fake,
One's
under
blocked,
seal,
one's
left
blocked.
hand on the other side.
But did you make
Easy
it?
good.
Yeah.
Well, I mean, we weren't in a basket. Like, he was
Wow,
just.
why do they have
Oh,
to
yeah.
He just goes, I need you to show me some post moves. I
Say
don't have
it.
any, yeah.
Oh, it's good.
Gave me some good ones.
Jerry went for it. Is it that time right now? I think
Yeah.
it is.
What?
It's
Or,
definitely a
I think it starts
Yeah,
at
oh, is
40.
it 40?
Yeah.
Oh,
I
I'm
think so.
into.
Unless I hit this shot, and then in case you have to start right now.
Oh.
But if you miss it though, there's a consequence.
Yeah, there has to be.
There's no free lunch, all right, Coach Shay?
Fountain.
Fountain. Oh, whoa.
If I miss
No,
it?
not for that.
No.
Yes.
No.
If you miss it, you can't start till 45.
If you miss-
You gotta give us
Wait,
5 more
Wait, what
minutes.
are we doing? Wait, so if
No.
he makes it, what happens?
Clock starts now.
You gotta give us donuts if you miss it.
No, one.
I thought-
Donuts?
Yeah.
Oh, I'm adding.
That's too much. For a
No.
missed shot
He's
from
considered-
there.
Yeah.
You have to give me all these tickets if you miss it.
No,
Oh.
no. He's a bad
Deal,
boy.
Grant, personally.
Alright, if I miss
Just
this,
snag a
then I
few.
have to. I'll be the chauffeur for you for prom. Whoever
What?
you want.
Okay.
So I'll drive you around.
If you miss,
Whoa!
let him
Like
shoot.
with
let
a
him
hat
shoot.
and
Let him
uniform?
shoot.
No,
How
no,
about
no.
this? Not if I miss. You got a chance to.
If he makes it, then.
Yeah, if you miss it, he makes it.
So if I make this, we start now. But if I
Yeah.
miss it, and he makes it, then you.
Yeah, there you go.
Yeah.
Here we go.
That's fair.
I might go to foul. I'll do that.
Oh.
Alright, well, make
That felt
that.
good. That felt good.
Donut.
Pass it back, pass it back. Well, by the time we got done explaining that class, it's like already.
Yeah.
Alright, well-
0% chance he makes this.
Thank you so much. You just have an
Not
extra
that
one?
long.
Nice one.
Oh!
That'll work. Thank you, man.
God, that was so close. Both of y'all were close.
Well, look, we got to start now. Let's go.
You made.
We got 1
30
minute.
seconds.
Hey, if you
I didn't
could get
get
this
tickets.
down real quick, let's discuss it, and then
Oh.
I'm gonna have y'all do something amongst your group here in just a second. So if you could just get these notes down. On the top, we pretty much have already said this already. High bias usually comes from a sampling, a poor sampling. Okay.
Oh.
All right, again, we're gonna do something where you're gonna be a little active here in a second, but before we do, I want to make sure you get this down. Okay. The second thing is low variability, and the best way to reduce variability, we already said, was to increase the sample size, right? We talked about how our hands, if we increase sample size, what happens? Right here, right? Right, we decrease that variability that's there, okay? All right, so here's the thing. Once you put those in, we pretty much have hit on this pretty hard. Here's what I want to talk about. Right here, we're going to pretend that this right here has a true parameter, which means it has a true proportion of 0.2, right? By the way, if I had a sampling distribution, how would I describe that? Not P, but what? P hat, nicely done. Good, Mary Martha. P hat. So when I look at my P hat, right? If 0.2 is my actual, but my P hat was 0.4, and again, I'd copy this down just so you could kind of see it. All these dots represent in a sampling distribution one sample, okay? So as I write this down here, you'll notice the fact that the mean of the sampling distribution is 0.4, but the actual is 0.2. Does that have high bias or low bias? High bias, right? Does that make sense? Okay. Sorry, Gary, I'll move it for you. Good. Okay. So this would be high bias because 0.4, which is the sampling distribution proportion, is not close to the true proportion. Okay. Also, I know it's depending on how you look at it, but it's really, really spread out. So we say that it has high what? Variance or high variability, right? High variability. Maddie?
So P is the same as mu?
I would be careful on that because mu stands for mean, P stands for proportion. Okay? Does that make sense? So the true proportion would be like 0.2. When we talk about true proportion of like when we flipped a coin, we said the true proportion over here was what? 0.5, right? Meaning if we flipped a coin, like in all the history of flipping a coin, we know that the average or the proportion of that would be 0.5. Does that make sense? But when we talk about the sampling distribution, the proportion of the sampling distribution would be P hat. Does that help you a little bit? But we expect that if we do it appropriately, we sample appropriately, and we take enough samples, if we increase the sample size, we'll have low variability. And what happens with P hat and P? They become closer together, which means that it has low bias. Okay? Like when the P's and P hat are together, low bias, right? Does that make sense?
Well.
Anyone need me to explain that again? Okay. Just write this down. High bias and low variability. Could someone explain why this one would be high bias but low variability? Max, roll, man.
Because it's higher, like it is higher, and then the variability is like really narrow. So like it's
I missed
not a big.
You rocked, man. Did you hear that from Max? Max, that was awesome.
Oh, Max.
So we said that the proportion, right, the 0.4.
I saw that. No one else did, but I got you.
I got you. Sometimes I just do it randomly. Right? I have my daughter trying to dab too. It's good. So P is 0.2, right? That's the actual. Notice the mean. Again, we'll call that P hat, right? P hat, the proportion of our sampling distribution, would be 0.4, correct? So that'd be 0.4. So that's high bias. But again, look at the variability. It's very, very tight, right? So we say that this has low variability. Okay? Are we good so far?
And if you look in the right corner, you'll see Coach Jay and the bodyguard he hired to get him through high school.
True. I did get picked on a lot. This is true. Okay?
Aww.
I did. They called me Squeaks,
And you still
Weasel.
do. Squeaks. Whoa.
Wait, you
Chill
still
out.
get picked on in high school?
Oh, man.
Wow. Wow.
That was funny. I'll actually admit that was a good one. All right.
I thought you
Oh,
pointed
man.
for you.
I should get a ticket for that? Is
No,
that
I
what
thought you were pulling him out for a grant.
I'll do it. That's fine. That's
I
fine.
will take it.
What
Thank
was-
you.
Why did I give him a ticket?
That's
Okay.
their village.
So as we look at P, all right, stay up here with me. As we look at the true proportion of 0.2, we're going to pretend that the center of our sampling distribution falls on that, right? This is really spread out, so this is going to have high what? Variability, but the mean of P and P hat are pretty closely aligned, so we say that it has low bias. Good. All right? But the idea, the perfect world, what would be the perfect world? The perfect world would be that we would have high bias, I almost said that backwards, and what? Low variability, right? Oh no, high bias.
Yeah, I was gonna say.
Yeah,
Low bias,
low
low
bias,
variability.
Come on, coach.
Come
Low
on, man.
bias and low variability.
There we go.
Come on, man.
I was
Low
like,
bias.
what are you on?
All right, stay with me. Low bias means the P and P hat do what? They're
Go
closely
like-
aligned. That means low bias. And then we know that when the data comes together in our sampling distribution, we have low variability. It's very tight. Therefore, we have what's called low bias and low variability. Are we good on that, depending on those pictures? Morgan?
Does P hat equal 0.4?
These top two, yes ma'am. So this right here, what I had circled, is that's where the center is at for our sampling distribution of 0.4. But on the bottom, it has low bias. So because of that, the 0.2, which is our true proportion, matches up with our P hat. Does that?
Yeah.
That's great.
What's
Great,
the
great.
difference between 2 and 4? Like I know one's for like the drawing
That's two.
itself.
Yeah. So the tightness of it is the same. So they both have low variability, but on the top one, the proportion is at 0.4 for my sampling distribution.
And where's the proportion on
At point two.
This one out down below,
Oh,
0.2 is both. I know I ran out of room, but 0.2 would be the P and P hat that are there. Okay. All right. So I'm going to show you a picture of my brother, and this will make you laugh even more. You ready? Okay. This is my bro.
Oh my.
Yeah. He's like,
Please tell me that's your brother on the left.
oh, no, that's me.
Oh.
Oh, no. What?
I don't know. This was me in high school.
That's
That
on
was
his
weird.
Oh my! I gotta take a picture of that.
No, no. We're gonna
No, no,
delete
no,
that.
It's on his Facebook page.
Is it?
It's
Okay.
on his Facebook page.
Oh,
yeah,
wait.
I was gonna say,
talk about what you said.
They looked it up last year in
No, I
our
know
math
you did.
class.
I know you did. I was
On
just
his
When did he
Facebook
post?
page.
All right, here we go. Hey, for tickets, and then we're gonna go. Yes, you may. Here we go. 2 more things, and then we're done.
No.
Yeah.
We're totally off task. We gotta focus. All right.
Okay.
All right.
Focus.
Focus. Increasing the sample size will decrease the
Variability.
variability. Good. 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 Matthew, but will not do anything to help the what?
Bias.
Nice. Good.
Ooh,
Good work there.
We should be-
All right. Here's the next one.
Soft snap.
If you have a high bias due to poor sampling design, which is true, we talked about that. What are 2 things that would be like poor sampling design? Someone stand up and tell me who hasn't had a ticket yet today. Give me an example of a poor sampling design. You don't have to stand up. You could just tell me on this. Great.
Convenient sample.
Convenient sampling. Nice.
Yeah.
Like it.
Convenience
Wait,
sampling.
he's got a ticket.
Okay.
Does that count?
All right.
Yeah, that doesn't count.
Or
Right.
what? What's another one?
Say, Grant.
Voluntary sample.
I would say voluntary would be nice. Nicely done. Voluntary. Sampling. Okay? So watch this. If you have high bias due to poor sampling, increasing the sample size will not decrease the bias. Someone explain that to me for 2 tickets, if you could. Campbell, go ahead.
So if you go to a baseball game and you're collecting samples from the first 20 people that walk in or so about what they think about the baseball team, even if you increase it to 100, you're still standing right outside the baseball game and getting a convenient sample of the people who show up to the game.
Gosh almighty, that was good. That was really good. No, I really like that. That's a good example of one, right? Because of the fact that the sampling design was poor, just because we increased the sample size, it wouldn't affect the bias that was there. The bias comes from not the sample size, but the way we did our sample. Make sense? Okay? All right, here's the deal. I want the first group, this is off your homework actually. These are 4 multiple choice questions off of your homework. So as you do this, you can get this down and actually do your homework there. But the group that is the first to get it done, but you must get it right. You got one shot at it, okay? I've got tickets for. So here's how this will work. I'm going to flash them up on the screen. You'll see all 4 there. You're going to see those multiple choice, and you got to solve them and figure them out. You ready? Go.
Hold on, turn on.
If you need to take a pic, you can.
I can't read that.
You want to take a picture, you can.
There's a lot of words.
A lot of words. Those are 4 different multiple choice. I'll give you about 5 minutes or so, okay? 5 minutes or so. Some of these. You can also Snapchat this if you want. You know, your followers.
Or tweet it.
Tweet it. Hashtag AP Stats Fam. 2017.
Throw the trash can.
That's right.
Oh, that was a spin
God.
turn.
I gave it to you, so I didn't have to get up on this.
Yeah.
All right, 5 minutes here, 5 minutes.
5 minutes.
Some of these should be quick.
Are 2 of the answers the same? I can't read. Oh, I see it. Okay, I know what it is. Yeah. But
He's not.
Tell you what, we won't even make it a quick thing. Your group, if you get it correct, I've got tickets for you. Don't even have to be first, okay?
Yeah.
I just need you to get correct. I will stop it. We'll give you about 6 or 7 minutes. I'll extend that a little bit.
Being generous with the tickets today.
I am. I'm feeling good today. Even though I get made fun of, I do. I feel good today.
Oh, really?
Well, I just wrote a person.
Yeah.
I made that number. Wow. Wait, I thought you still did that. I agree. I couldn't have done it better, actually. I was thinking more about it.
Yeah.
But yes. I think so.
Think what?
what's over
Yeah.
there?
I think you're right. That's mine. Yes.
That's good.
It's just close number, so it most likely to be off. The 20 is what we're asking about. It's quantitative stuff, right? Or is it like
What's in
Number 24?
Yeah.
So quantitative, yes. So we're saying that all of this is
That's the end of number of trials.
is the opinion poll like is that like
Okay.
that's like I don't know if that definitely would it would I think
So-
Oh, y'all are doing 20.
of an opinion poll. I would say that was like, hey, on a scale of 1 to 10,
okay.
how do you prefer this high low?
I really don't like it.
Let's see what
No, we're just discussing, you know, me and multiple choice don't really get along very well,
Me, I didn't either.
I'm talking them out of the
Either
answers,
be-
is our problem.
Yeah, you
I'm
are.
sorry.
Yeah, it won't reduce the rate.
I don't know how to feel anymore.
It's easy to do that with, isn't it?
Yes.
I have a hard time with, or I had a hard time with it. On SAT.
My last
SAT.
test was a
Technically, I just
miracle,
have
I
this
only
woman
missed one.
speaking in my
You're
time,
right.
like this.
And by the way, Mayor Martha, I didn't see your test, but I updated it.
Which
You
one
did?
is most likely to be
Maddie, I don't know, or Morgan, I'm sorry. I didn't know if you were here or not, but we were just looking at these four here. So.
I was at both two or three. We don't know, we look, it just is most likely to be.
I know it's harder to see, I'm sorry. All right, got about 2 or 3 minutes. Y'all locking them in?
I feel like trying.
The statistic is like, the hard statistic is that 78% of population are have financial.
Hey.
Where's your last one? Last one, or not last one. One of those are incorrect. You can fix it. We're good. I'll let you have one more. You want to check with me once before? I'll give you one other shot. I'll tell you how many you have incorrect, and then we'll go.
Just one?
There's one.
What?
Sir. Yeah.
That's not
Alright, well, while he's doing that, let's go to 20. I'm gonna go.
I've already
The
done
one, I feel like, we were arguing between.
What did you get for 20?
All right, you have to have answers locked in 2 minutes. 2 minutes.
Possible to determine.
I'm positive.
I probably go with it. Yeah. I think we should probably.
Yes, ma'am.
What's your
Maybe
view?
because we don't know how they
We
would.
can't actually solve.
There's nothing to
It's not a grade or anything. It's just from our homework. And I'm just curious to see where we're at.
We'll determine because we don't know the statistics.
That's what I'm saying, but I think we need to go bigger and like put it in bigger words. Alright,
What are you
Coach
talking
Jay,
about,
can we get a
22?
check?
23 is
Can we get a check, Coach Jay, to see
Check.
our four?
I'll talk through it in a second.
Oh, you didn't write them all down. Those are A.
Wait.
Both of those are
Before
A.
we answer.
What's
Three
one?
different options of parameters.
It's C, yeah.
Or that's why we said it was C. Yeah, 'cause then one of
Sometimes that's right.
But no,
Either way,
it's
it's
AA.
change it. One of those is incorrect.
Okay.
Yeah, we're good.
All right, they need to be in about a minute or so. Did y'all get it?
Yeah, I think so. We got it.
Y'all figured it out?
We're still figuring this out here.
Still figuring it out? It's okay.
I think we're good.
I think so.
Still see one out there.
Really?
Wait, what?
Wait, so did you see multiple before or just one?
No, I only saw one.
Oh,
So
so
the
we
one you
still have
changed
that
is-
one
So
problem.
the one we changed is.
What you change is not wrong.
No, the one we changed is still wrong.
We changed the oil and we didn't change the
No,
temperature.
yeah. It was one before.
Okay, well, I guess.
Y'all get it?
we already got you a vote.
Got it down.
Good.
I think we're fine, but I don't know.
Oh.
Do you wanna lock them in yet?
No, I think, well, he's doing another shot, so I mean, I think we might as well at this point. Alright, let's try this again.
Oh,
Is what's A again?
Lock these guys in a little bit.
I'm not
22.
total
A
bad.
is about one.
Yeah, that's what I'm saying.
Top right.
That's
Oh,
what I'm saying.
well, then mine's opposite.
Then you have one incorrect. I figured that as much. You have one incorrect.
I don't know about
I'm
this.
Y'all get it
very
now?
confused.
I think that makes more sense.
5 A.
You do?
We'll go with that.
Two examples of 5
Ella,
A.
yours, I see one that's incorrect.
Alright, let's see if we get this one wrong or not.
Okay.
I wanna know if we actually get
Alright.
We have multiple wrong now, that we know we have the one right. Alright, so it's not, we had
Two?
we had 23 right.
Okay, Coach Jay.
That's 21 and 22.
Oh, D.
Or no.
I'm gonna
Okay, I think I've checked everyone's.
Alright, okay, we will get.
Everyone
Can
got
we
one.
get it
Is this
right?
Everyone got one incorrect. That's okay though.
C Dad.
All right.
Is that
Is
right?
all the same
22
one.
is A.
C Dad? Is that it?
We'll see.
Did we all get the same one?
We'll see.
All right. Hey, let's talk about the first one, and then we'll go through them, and then we'll rock and roll. Okay.
We got 23 right.
21. Particular college, 78% of all students. Stop right there. If it's all students, let's talk about what they're referring to. I think all students, if we keep looking, they're saying in school newspaper selects a random sample of 100 students, my population, or my parameter, rather, because parameter is the value associated with population, right? 78% would be referring to the population, the whole. So we would say that this one would be, it would be a parameter, right? Referring to the population. So we know that for this one, it's got to be either C, D, or E with A and B eliminated because it's not a population, though it is a part of the population. It's really a parameter. Okay, that's what we're referring to. So now what's 72% of the respondents from the random sample of 100 students? 72% relates to a statistic. Okay? So 72% is a statistic, therefore C is true.
It is.
Right.
Alright.
Alright. Number 22 is the most missed one. I didn't see one correct answer. Okay?
Really?
Let's talk about this. A statistic is an unbiased estimator of a parameter when A, the statistic is calculated from a random sample. That might be true, but that doesn't mean it's biased or unbiased, right? So we're going to cancel that out because that could be true, but it also could not be true. In a single sample, the value of the statistic is equal to the value of the parameter. That's actually partially true, but there's one word that kind of throws that off. Single sample. Do we ever take a single sample and say, oh, I flipped a coin, got heads the first time, and then got tails the second, therefore, no, you got to have multiple, right? You have to have multiple samples. C, in many samples, the values of the statistics are very close to the values of the parameter. Now, this is where it gets a little tricky. Because we can either have C right, and you're going to see how two of them are closely related. D says, in many samples, the values of the statistic are centered at the values of the parameter. I'm going to come back to that one. And then E is, in many samples, the distribution of the statistic has a shape that is approximately normal. Now, that is awesome. That is, again, remember, sampling distribution will do that if there's more samples, right? That will happen. But because of the fact that they say it's normal, that doesn't make it unbiased or biased. Okay? Right? Does not make it biased or unbiased. So the question is C and D are the two answers, but there's one carrot, okay, that they throw out there. Here's the thing. In order for it to be, if it's closely aligned, okay, if mu and x bar are closely aligned, there's low bias, but there's still bias. Does that make sense? So, let's say one mean is 3 and another one's 3.01. Even though, yes, it's very, very small, there still is a little bit of bias there. So to be completely unbiased, we have to have our statistic and our parameter do what? It's got to align. It's got to align in center at the same value. That's
our
why.
third guess.
Okay, it's true. Does that make sense? That makes sense there. 23, a lot of you got, it would be A, right? Because the smaller the sample size, that's why 250,000 is a lot further away than 200,000, right? How can we get those two to align together? Larger sample size, right? Larger sample size there. Emily?
Just say that increasing the sample size won't reduce bias.
Increasing the sample size,
I know.
correct. Oh, are we talking about bias? No, you're right.
Get her.
Are we talking about bias right now?
Yes.
Well, we don't know if like the sampling method was correct or not.
It's true.
So that's why we changed ours to E.
You changed yours to E?
Like originally. Like after you told us we had one wrong, we changed that one to E.
Oh.
Because we don't
Emily,
know
I think you got me on that one. That's good. I think you got me on that one. Because it is. Because we're talking about our median or mean. Therefore, we are talking about bias. I got mine mixed up. Because if we were talking about variability, then in that instance, that would be correct. We'd go with the lower value. But because we're talking about bias because of the fact that the median of the parameter and the statistic are so far away, yeah, that's a really good point.
Which one? Oh, are we talking about 22?
We're talking about 23 right now.
23. 23.
I think A is definitely
Okay,
most
okay.
likely.
I think I'm right still. Because
Yeah.
here's the reason. N equals 10 means what? That's the amount of samples that I am taking, correct?
Mhm.
Right? N equals 10 is the amount of samples being taken. That is not talking about the sample size. Does that make sense? So, okay. So let me
Okay.
hopefully this makes sense. So if I increase, trying trying to use, let me use this. This hopefully will help us. Okay? If I was trying to decrease the variability, instead of choosing 4 students to be able to find the average siblings, what would I do? 8, 10, something larger, right? Does that make sense? But when I talk about n equals 10 refers to the amount of samples that I find, not the sample size.
So that would be like 10 groups of 4 students.
10 groups of 4, right? So we would say that in this instance, 10 would be the least amount, right? Therefore, it would affect bias, right? Because the more samples that I have, right? The more samples that I have, the larger I get, the more the mean of those samples goes closer to my true value. Emily, does that make sense?
But the question says for which of the following sample sizes?
For which of the following sample sizes?
That's what you were doing over there. That's like 4, 8. That's what you were saying over here.
Yeah, it's still.
Would you do a sample size of 10 houses, a sample size of 50 houses?
So I actually, so I see what, so I was wrong, I'm incorrect. I'm gonna find it, okay? I'm confusing myself right now, if I'm honest. Because this right here is, which of the following sample sizes?
Yeah, because what you just said made sense, but then the question is asking the sample size.
Gotcha, so this, I'm contradicting myself, is what you're saying. So
Yeah,
I would
I'll
say,
look it up in the book.
I would say E, check me on this. But regardless, here's the deal. I don't like my answer either way. I'm going to come back to that one. Is that cool? Emily, that was
It's
a great
A.
thought. That's a great thought.
It's A.
Is it A?
It's A in the book.
Maybe they just misworded it.
I don't like the wording, you know? Because here's the reason why. When you think of n equals a number, little n, refers to the amount of samples that you select, not the sample size. What throws me off, and this is probably what threw you off too, Emily, is the sample sizes. I don't like that wording of that question. So if I saw that and I saw that on a test, well, first off, I hope that the AP exam wouldn't word it that way. You know what I'm saying?
It just says which one is most likely to affect the mean being greater, and that would have to be like if you had 10 houses. That was how I thought about it. If you had 10 houses rather than 50, 100, 1,000, the smaller number of houses you have, the more likely your mean is going to be greater than.
Correct. But what we're saying is, and I get it, is that when we talk about sample size, that we're talking about one individual sample, we increase that sample size in here, right? Not increasing more. Does that make sense?
The mean
I'm
and the
hearing you
median
out.
refers to the bias, not the
Right.
variability. So, and then it says sample sizes, and the sample size isn't supposed to affect the bias. So it should say which of the following number of samples is the median most likely to be equal to.
Here's the thing too, and this maybe should eliminate this right here, is the fact that whenever I see n equals 10, little n refers to the amount of samples I selected. Is that cool? Does that make better sense? That was weird. I don't like the wording on that one. Don't like that question. I hope that makes sense, right? Hope that makes sense. Maybe it will once we keep going, okay? Last one, increasing the sample size of an opinion poll will reduce the what? Well, again, increase sample size. This is different than over here, right? This is increasing the samples. This is increasing sample size. What happens to our variability? Decreases. Therefore, the only one that I saw was variability of opinions in the sample would be the one that will be reduced. Okay?
All by herself. She got B all by herself.
Independently.
14, that didn't make sense.
Variability of-
We had one wrong.
Good try that.
I think this, I forget which one it was that y'all had. I've got to go on and see which one y'all had. Okay? But it should be CDAD is what I saw, and it might have been scattered, so I might have messed up on seeing that. Okay?
You were looking at Matthews, so.
It could have been, yeah, I was looking at Matthews, so that could have been, maybe someone had something different. All right, how we doing? All right. Hey, this right here again. Don't get hung up on this. I don't want one question to like get us down. This is a weird question. Honest, I know that. Okay. All right, are we good?
All right.
Okay. All right, let's do this. Hey, I did get something as we go to the next part of the notes. If you want one, pass it around. Need a little pick me up. I get it. Let's go to this next one here. And I think this builds on that same idea. In fact, I know it does. That same idea. However, these notes right here, we're going to kind of go through at a pretty decent clip here, okay? All right, so we'll say this. Reese's Pieces. My wife loves Reese's Pieces, whatever. Okay. And what we're gonna say is this: that there's 1,000 pieces that we have in this huge population. Okay. And we know that exactly 40% of the candies are orange. Okay. Now, question: based upon that, what do we know about mu? Well, be careful. It's not mu. It's what? 0.4, right? Well, 1,000 is our population, right? So wouldn't it be our p? Our probability would be 0.4, right? We're good with that? Okay, now let's pretend that x is the number of orange candies in the sample, okay? What are the possible values for x? Because we're sampling, we don't want to count 1,000, so we're going to count 50. So what are the possible values for how many oranges I could possibly have there?
0 to 50.
Perfect. So we could go 0, 1, 2, 3, all the way to 50. Okay? We know that. Now, here's the thing. I've got tickets for you on this one. Okay, yeah, go ahead, Grandma.
Why does it go to 50 if there's only 40% of the candies are, because we're taking a sample.
50
Never mind,
pieces.
I got it.
Good question, because
Because
each
we
one
could.
that I select, right, just like the Starburst, is what? What's the word for it? Each one I select is
Independent.
If you put it back.
good. Good, Mary Martha. So each is independent of the next, okay? So here's the thing, okay? For 2 tickets I got you here, what type of distribution, someone that hasn't gotten a ticket today, what type of distribution is this? A normal distribution? Now it could be, over the course of time, it could be, and we're going to talk over that, but I think we've got a better answer. Morgan, you got something? Okay, population, if we did all 1,000, right? It's a sampling distribution, but specifically it was something we talked about last chapter, Morgan. You remember?
Probability distribution.
That's okay. B.
The probability distribution.
Okay, probability would be 1,000 pieces, right? But with 50, don't we have a sampling distribution? Here's a question. What type of sampling distribution?
Oh.
You're all over that. That's close. That's close, Maddie. What type of discrete random variable are we using?
Now I'm
Discrete.
lost.
Net random.
Oh, yeah.
Which one?
Oh, binomial.
Binomial, right? Binomial. Think about it. All right, let's look at it. Is it binary?
Yes.
How?
It's either orange or it's
Yeah.
Orange or not orange, okay?
Excessive,
Good.
yeah.
We're going through this quick, so eat your Starburst. If you need another one, pick me up, that's fine. Orange or not orange, good. All right, look at the next one. Is it independent?
Yes.
We did, we just said it,
Yes.
right? What I get on my first selection? Good, Max. So it is independent. Max, do you remember what N represented? And Ben's here? Anybody else? Morgan, you got it?
Number of trials.
Yeah, number of trials. Is that set?
No.
Oh,
Yeah,
yes.
Yes,
50, right? Good. So we've got all 3 of these checked off. You ready? Now the next one, huge concept. You need to get this right now. That's why I gave you Starburst. I'm trying to bribe you. I'm not even going to deny it. Okay, I'm trying to bribe you. Okay? No matter how much you make fun of me, I'm trying. The S stands for what? Success.
Of trials.
So success is what?
How many times the variable happens?
40%.
Is the same. It's the same every time, right? Now we don't know what the success is up here, okay? In terms of, well, I say that. We just know that it is the same, okay? Now here's the kicker. Here's the kicker, okay? Success percentage is the same. In order for you to use a binomial, my success percentage must be the exact same, okay?
So like 50% are orange or 50% not orange?
Correct, except it's 40%, right? Are orange. That's a set percentage. However, we got to look at this, okay? This is different. Does anyone have the,
It's right there.
all right, here, perfect. All right, so let's say I had 1,000 in here, okay? These represent Reese's Pieces. We know that 40% of these exactly are orange, okay? So I take a sample of 50. When I select one, if this one is orange, and it was, look at that. Sign, okay? Let's say this is orange. Question, when I select another one again, is the probability that I will select another orange the same?
No.
You see the
Well,
problem
and
with that?
1,000
Do you remember that?
yeah.
Remember last chapter I said that's true? Remember that? Remember I said good, because the success percentage would be different, would it not? Because I already selected one orange or didn't select one. So really, technically, technicality, is this true right now?
No.
No, it is not. However, if
There's
we
a
have a
1,000.
large population and a large sample that's big enough, we can say, remember this? We can say that we could still use binomial, okay? How big does it have to be? That's the question. We talked about this already, but how big does it have to be? That's a good question. And that's where we go to this next part. We call it our 10% conditional, okay? This is important, all right? This is important. So, why do we use it, okay? Why do we use it? Because this is without replacement over here, okay? Without replacement. Shiloh, your test is right over here on this right side, okay? Because this is without replacement, it's not going to be the same. However, we can estimate this and say, you know what, we could still use binomial when going through this by doing what we call our 10% condition, okay? And we're going to come back to the y, but the formula for this is as follows. N must be less than or equal to 1/10 of my population, okay? All right, now that seems like, oh my gosh, that's real, are you serious? It's really not that bad. Think about it. What's my sample? What's n? How many samples did I select? 50, right? That's little n. Is 50 less than or equal to 1/10? What's my big N? 1,000. What's 1/10 of 1,000? 100. Is 100 bigger than or equal to 50?
Smaller.
Yes. So we say that in this case, the S, or the success percentage, even though it's without replacement, we can say that we can still go through with the binomial because it's big enough. All right? Questions? All right, does that make sense? We just call it our 10% condition. Emily?
If it's not, will it make the result also dependent instead of independent?
Not necessarily. Oh, I see where you're coming from with that, because those are really tied together.
Yeah.
The independent and the dependent. I could see that and say yes. We could. What we're saying is, if it wasn't true, we would just say that we couldn't go through with the binomial
Okay.
and go from there. What's not big enough to estimate using a binomial? Does that make sense? Because this is big enough, using the 10% condition, we can go through with that. Okay, so we can go through with this binomial that's there. All right, how we doing? That's a big deal. You have to show that if you come to one on the test that's similar like this on an AP exam, you've got to show the 10% condition if they don't tell you already that it is a binomial. All right? How we doing?
Is that on our
Rocky.
formula sheet?
This is not on your formula sheet. So here's what you just remember: 10% of the 10% condition is my sample. Okay, less than or equal to 10% of my population. If you remember that, you'll be good to go. Okay. All right, and we'll practice this too. All right. So, question: what is the standard deviation for tickets? What's the standard deviation of the distribution for X?
1.
How do we find that?
Cool.
Did you say 1?
He says
If it is, man, I'll go jump in the fountain now. No, it's not. Okay, good. What is the formula for my mean? This is on the formula sheet, n times p, right? N times p. So if I took my number, in this case 50, multiplied it by, what's my p? 0.4.
Oh.
50 multiplied by 0.4 produces 20. Good. Okay, that's my mean. I have a purpose behind this, so keep rolling with me.
Okay.
If I come, thank you, Matthew. Appreciate you.
Okay.
My standard deviation, you keep it alive, man. I love it. Is the square root of n times p times 1 minus p. You're like, what the heck? That's on the formula sheet. Okay. Now, what one is not on the formula sheet? Geometric. But this is
Can
binomial,
we write it in?
so we're good. Okay.
Can you give us a pass to write in the geometric formula for standard deviation?
I'll call it the AP stuff, and I'll let you know. Is that cool?
Yeah.
Is that cool? I'll let you know. Hopefully, that'd be cool. That'd be really cool. All right, so when I do this, I get right here, if I calculated, threw it in, plugged it in, I would get a standard deviation of, I got 3.46, but check me on that. I think it's 3.46.
Would P be point? Oh, never mind.
Got it? All right, so someone, real quick, interpret this for 2 tickets. I'm feeling it today. What's the mean? Interpret the mean for me. Maddie.
The average number of orange species that will be in the.
I like that. Could someone refine that? Add one word to it that would just be perfect. Just beautiful.
Approximately.
What was the question?
If you
expected,
draw-
expected.
Yeah.
Expected.
No, I was saying if you draw 50 starburst, you should get approximately 20.
I would say all three of you were a great team there and came together on that and said that perfectly. Okay. All right, Ella, I saw that hand. I'm gonna come to you. Okay. Could you interpret 3.46 with standard deviation for me?
On average, the number you pick from 50 starbursts that is orange is 3.46 away from the mean.
Awesome. That was great. That one's harder, I think. Don't you think? That one's a little bit hard. All right, here we go. All right, now this, if we sketched an approximate probability distribution for x, right? What do you think that would look like?
Probability distribution.
What would be the highest? Like, what would be the highest there?
20.
20, good. 20, because you think if I selected 50, right? I would say that in all of those samples out of 50, I would say the highest, right, would be about 20, right? And then what would happen
you meant by
from
the
there?
high. Whoa, I thought you
meant.
meant.
In the far right.
Yeah.
Say that one more time.
We thought that you meant like the one that was far right side, like the most you could get.
Oh, might be.
Yeah,
Yeah,
that's what we
might
thought by highest.
Do you see what I'm saying?
Yeah.
The highest as in
Yeah, I
the
would.
tallest. That would be the mean expected value, right? Would be 20. So we know that it would slowly progress downwards. Question, all right, if we get a lot of samples, right? A lot of samples. This thing is going to do what? Well, it's going to look a heck of a lot like a...
Normal distribution.
Awesome. This sounds like a lot like what we talked about prior to, okay? So again, each of these, if this was 20, this would be 21, 19, and this would go down and down and down to the right, to the left. But this is going to approximate a normal distribution, okay? Now here we go, part 2, okay? Part 2, really big part right here, okay? And tell you what, I'll do this, and I'll do 2 more blanks, and we'll do character development to finish this out, okay?
Yes.
All right, but I need this part from you real quick. When I do a normal distribution, I don't know whether this is normal or not. True or false? True. But I can pretty much have a good idea of whether it's an approximation of a normal distribution with my next rule that's called the central limit theorem. Okay? It's called CLT. Okay? I made that up, but CLT.
Like instead of the old.
Central limit theorem. Okay? So how do we approximate this? Well, if 2 things are true, we can say a binomial approximates a normal distribution. 2 things, right? If n times p is greater than or equal to 10, or if n times 1 minus p is greater than or equal to 10, we say that this binomial approximates a normal distribution, okay? So for instance, in this one, does this as a whole appear, does that approximate a normal distribution with what we just talked about?
Yes.
Okay, what's n then?
N is 50
50 times 0.4,
so
which is?
20
Is 20 greater than or equal to 10?
Yes.
Yes, so my part 1 identifies that, you know what, for the first part, we got it.
It
We're
has
good
to
to go.
fit both.
It's got to have both.
Oh,
Okay.
man, wow.
But think about it, if this is 0.4, then 1 minus p is what?
0.6.
0.6.
12.
So when we do 0.6 times 50, we get 30.
Oh, man.
Is 30 greater than or equal to 10?
Yes.
Yes, it is. So because of that, based on the central limit theorem, we can say that this binomial, when we use this as a sampling distribution, will approximate a normal distribution that's there.
Say that one
Okay?
more time.
Absolutely. So if the central limit theorem is true, that n times p or n times 1 minus p, that they're both greater than or equal to 10, we can say that in this binomial, in this sample that we just took of the 50 Reese's Pieces, we can say that this sampling distribution, right, approximates a normal distribution. All right?
Is it or and both of them, or
Both of
just
them have to
one?
occur. Both of them
Alright.
have to occur. Maddie?
Is 10 like a set number? So like that's the formula. It has to be greater than or equal to 10.
Correct.
So like even if it was just like a completely different problem, it would still be n times p is greater than or equal to
Correct.
10.
This so why do we use this? Why do we use it? Could someone put that in
I'm
words?
guessing the 10's a big enough number to test if it's normal.
Yeah, you all said it perfectly. Mary Martha and Campbell, both of you, heard both of you, that's awesome. So we would say that this sampling distribution approximates as a normal distribution. That's kind of wordy.
They're just saying that 10 is like a big enough number to consider something approximately normal, right?
Correct. So we're saying based upon the sample that we're taking and the proportion, can we say that this sampling distribution is large enough, you said it, to be able to be approximated as a normal distribution? Does that make sense? So question, is this large enough? Just the dots.
No.
I would say probably not. When you do that, it's probably going to be less than or equal to 10. So because of that we wouldn't be able to use or approximate that as a normal distribution. But if we did it like 100 times, we could probably see this start becoming more of a normal distribution that's there. Okay?
So for that one, what are we using as the probability though?
B was 0.5, and then we had 16 people in our class.
This might be a bad example because we don't really have a
That's not-
probability.
that's-
It would be more
that was
like the
number
one
plus
up
the other
here.
kids, Yeah, do that.
It would be
Number
more
of
like
siblings,
this because the
yeah.
probability would be what?
Yeah.
0.5, right? 0.5 on that. Any questions on that one? All right, I told you that we were going to finish these and be done, so let's roll with it. In this section, we will not be concerned with number of orange candies, but rather of the proportion, okay, of orange candies in the sample. How do we turn all the values for X into proportions? That's a good question.
Multiply by 100.
Say that again, Maddie. I heard you first.
The number that you pulled out would be the total number of candies
You rock. Yeah, so divide each by what?
the total number.
Which, the
Or-
total number by?
Probably
Each by 50, right? Which, that was a total
That's
number
your
within
sample.
the sample.
Yeah, total
Yeah.
number of
Why the
samples.
sample and not the population?
Right.
Good question, because what is X? X is from, we're not talking about the populations, we're just from the sample. Good question. Okay, next one. This is our last one. If we were to take a sample of 50 candies, record the proportion of orange candies, what would we expect to get? We already said this already. We would expect to get 40, right?
Wait.
Oh, hold up.
20.
Sorry. 0.40, which we call, because we're talking proportion, which is P what?
Yeah.
P hat, right? Does this mean that every sample will give this value?
No.
No. Yeah. No, it won't, right? Now, what could we expect on that? Well, we could expect that it would be no because of, due to, and this is a good word, sampling variability.
It's a big two.
Ooh.
Sample
Nice. All right.
variability.
All right. Last question, and then I'm done. This is just bonus.
Good,
This is
Jerry.
extra. I appreciate it. I know this is heavy today. I get this. It's hard to talk through. But this is kind of my last question, then we're done. What is the difference between a population distribution, a sampling distribution, and a sample distribution that's there?
Can you repeat that?
What's the difference between a population distribution and a sampling distribution and a sample distribution?
Oh
Okay?
I mean, I know the easy.
All right?
my. They all have different words.
Matthew, go ahead.
Alright, so population distribution is all of the all the entire population. So like for example in this one it'd be like all 1,000 candies.
Perfect. Hold up right there. That's a population distribution. Everyone clear? All 1,000 Reese's. All right, hold off on that. What's a sampling distribution? Let's go, Emily.
Will you select samples from the population and you get a distribution from that?
Good. How many? Do you know? It doesn't really say, does it? But size of what? In this case,
50.
size of 50. Great job. And then this is the weird one. What is a sample? Sampling is a bunch of them, right? A bunch of 50s, right? What is a sample distribution, Maddie?
Just one of the 50, one of the samples.